Alright, so now we're going to move and rotate our player. Looking at our game, it really sucks right now because we can't actually do anything. If we're just looking at an art piece, that's not a fun game. So, how do we begin moving our player? Well, we need to determine what keys we want to use to begin moving the player. We can use our arrow keys. We can use, I don't know, I, J, K, L. Pretty much anything on the keyboard you can use to move your player. And in my case, I always like using WASD. That's pretty standard for things like first-person shooters. And I'm just so used to that, so I'm just going to use that for this tutorial. And I'll try to do it in a way that is as easy as possible for any of you guys that have international keyboards. I'll show you how to use basically the correct key code so that you're not really fiddling around too much with activating the correct keys. So to listen for events, whenever you press down on the keyboard, this is what I'm going to do. I'm going to go to the very bottom of our file. This is typically where I add things to start, in regards to events at least. And I'm going to reference our window object, the same one that we were calling when we referenced inner width and inner height. Now this window object has a method called add event listener. And this says, listen for a particular event to take place within the browser window. And there's a whole list of these. Some examples are mouse click, touch down when you're pressing on your phone, key down, key up. There are many, many more, honestly. I can't remember them all off the top of my head. But I do know the one we want to focus on is key down. So whenever a user takes their finger, presses on their keyboard, we're going to activate an event, and we're going to activate this event for the keys WASD. Now, when we key down, we want to add a second argument, and that second argument is going to have a callback function, just a simple arrow function that looks like this. So whenever we key down, we're calling whatever is inside of this arrow function. Cool. Now, how do we determine what key are we currently pressing? Well, this arrow function right here has an argument associated with it by default. And you can really name it anything you want, and it'll reference the correct object, but it's pretty good practice to name this something which the object represents. And in this case, it represents an event object. So I'm going to call it event. So if I key down and I console log out event, when I go back over here, refresh, inspect our element, you know the deal. Go over to console, click on the screen, and then I key down. Here we go. I'm going to hit the key H. You're going to see we have a keyboard event being logged out. If I open this on up, we have all these different data properties associated with the event of pressing down a key. Fascinating. And we have things that we need to help tell us which key we press down, like key, key code, and even just a code property, which is equal to key H. This is what we want to listen for when listening for key events. Particularly me, I'm going to listen for the code key H. Why am I using the code of key H and not just key? Well, if we use the key property, what happens when you press caps lock and then you press H? You're not going to be listening for the same key, that is different. But if we use the code key H right here, we're going to be getting the same value for uppercase H or lowercase h. Watch, if I hit shift, or not shift, caps lock, click on our screen, hit H, scroll down, we're going to have a new key event. There it is. You can see the key right here is uppercase H, but the code is still key H. That is exactly why we're going to be using the code property and not key in this case. But to begin listening for those keys, we can add in a switch case statement. So what is a switch case statement? It's basically just an if-else that makes things a bit cleaner. So we can switch out a particular variable value. What variable value do we want to switch out for a particular event? Well, we want to reference our event objects. What? Our event objects code property. This right here is going to be equal to this right here. And if we add some opening and closing curly brackets, we can listen for particular cases in which event.code might be equal to. One particular case is going to be key with an uppercase K, key W, because that is going to make our spaceship go upwards. And then once we have that case, we want to make sure that we add a colon and then a break statement, which says we are done with this case. So any code that we want to write, whenever we press key W, we're going to write in between case and break right here. We can console log out some text that says W was pressed. So we can press a bunch of keys, but only when we press W will this text be logged. I'm going to delete our previous console log, save and refresh, and just go ham on the keyboard. I'm not pressing W yet, but if I press W 1, 2, 3, 4, 5, 6, 7, 8 times, you can see we're console logging out W was pressed. Cool. So we have W in place, but what else do we need? We need A and then D. We don't really need S because I'm not going to include backwards functionality. You can add it if you want, but I really just want to be able to go forward and then rotate our spaceship left and right. So let's add in those other cases. If I want to listen for other keys, I can add in a case in which I just duplicated the 3 lines above, and then I can listen for a key of A. What happens when A is pressed? We're going to log out. A was pressed. What's next? We also have D. What happens when key D was pressed? We're going to log out. D was pressed. We'll do a quick save and refresh, and then hit those keys in particular, A, D, W, and then click everything else, and you're not going to see anything because we only added in console logs for these particular keys. So what is up next? Well, we have the key events in place, but now we need to actually start shifting our player around. And in order to do that, we need an animation loop, because right now we're just calling our code once and that's the end of it. An animation loop is going to call this code over and over and over again, and that's how animations are created. They're just a bunch of frames intertwined together and played really quickly to make it look like as if things are moving. I always found that quite amazing when I learned about it, because stupid-brained me that did not know about it, I don't know, I just found it quite incredible to know that these are multiple frames being played over and over again. So to create that animation within code, I'm going to create a function called animate. It doesn't really matter where you put this, I'm just going to randomly place it here. And within this function of animate, I want to reference our handy window object again. And this window object has a method called request animation frame, and it takes an argument. It basically says, what function do we want to call over and over and over again? That function I want to call over again is going to be animate. So it's a little weird because we are calling the function itself within the function. Basically, the way you want to think of this is when we call request animation frame, we are just going to go back and call animate again. And when we call animate, what does that do? It calls request animation frame, which in return calls animate. It's just going to create this infinite loop until we tell it to stop. That's exactly what we want. We want to create this animation loop in which we can begin altering our player's movement. But in order for this to actually fire, we need to make sure we're calling animate down below, or else the code will never run. How do we test if this works? We can always console log out some text. We'll put an animate there, and now we should see this being called really quickly within the console. So inspect, go to console, refresh, and there it is. Animation loop's working. Perfect. So we want to start moving our player around, and for every frame we're within animate and a user has the W key down, we're going to start shifting the player based off of a velocity and speed value. And here's how we're going to do it. I want to listen for when we are pressing down the W key. So if out of all of our keys, the W key is pressed, I want to take our player velocity, and to start we're going to use player velocity.x, and I want to set this equal to 1, which means our player should start moving to the right whenever W is pressed. Now, can you see some things wrong with this code right here? The first thing is we have not declared this property or this variable of keys. If this does not exist, we cannot reference it, so we need to make sure that we actually create it. So right above animate, I'll create a const, call it keys, and set that equal to an object like so. And this object is going to have all the keys in which we want to listen for events. I want to use a W key because that's what we're listening for, and I want to determine whether or not W is pressed. By default, it is not pressed. So whenever we press the W key down, which happens right here within this event listener, we're going to take that keys object, reference W, and then set its pressed value equal to true. Now animate's being called really quickly, remember, tons of times. And if on one of the frames this is set equal to true, then we're going to activate the code within this if statement right here. Player.velocity.x is equal to 1, which should move our player to the right as long as we finish things off correctly. So how do we finish things off correctly? Well, right now, we're only drawing our player once on code load. I like the rhyme there. When we load the code, we're calling player.draw on line 38, but within animate, we're never calling that again. We want to call this for every frame. We call animate because as we begin updating the player's values, such as position, we need to make sure we draw the player out in that new position. So let's grab player.draw, and then right after we call request animation frame, I'm going to call player.draw. But we don't currently have a way to actually update our player's values. You can see up here, yes, we're drawing out our player at position X, position Y, but we're only setting player velocity.x equal to 1. None of these values right here use player velocity. So what I pretty much do for all my games and all my objects is I add in one more additional method called update. And what update does is it calls draw. So all the draw code right here is going to be called immediately. And then I want to start altering our position X and our position Y and always be increasing that exact value by whatever this dot velocity X is. So our position is going to be updated per every frame based on the velocity on our X coordinate right here. To illustrate this, let's say our player is right here. Velocity is going to be equal to 0 by default. That means we stay in place. But if we set this equal to 1, we're going to start moving to the right for every frame. So first frame fires, we move over to the right. Second frame fires over to the right, and then so forth. We're just going to keep moving until we either set this velocity equal to 0 or we stop our animation altogether. But we always want to be updating our position X and position Y for every frame in which we call update based on our velocity X and our velocity Y. Now, if I want things to update accordingly based off these velocities, instead of calling draw within our animation loop, I'm going to call update. So we're no longer just calling this code. We're calling this code, which in return calls this code. A little confusing, but nothing you can't grasp, I'm sure. So draw and then update the values and then draw again. So let's see what this looks like. When we press W, which is supposed to go up, for whatever reason, we're going to the right. Funny stuff. So this is what things look like. I don't know why we're red. Doesn't really matter right now. But if I hit W, you can see we are going over to the right. And we cannot stop at all. And we're just drawing this really weird trail. So what's happening here? Well, yes, we are updating our player, but one of the issues is we are not clearing our canvas for every frame of our animation. We are only clearing our canvas once. Can you tell me when that is? We're clearing our canvas on basically load. And that is right here at the very top of our file, 7 and 8. I'm going to grab these two lines, and right before we call player update, I'm going to call these two lines, which just draws a black rectangle from the full width and the full height of our canvas. It's basically going to give us a fresh slate to draw on top of. And if we have that fresh slate, we can call player.update and things are not going to draw with a snail trail. So let's save, refresh, and then hit W again. And we still have the same issue, even though we cleared things. So that's kind of annoying, but I think I know what it is. If we go over to our draw method, I noticed that I didn't actually include begin path, which is kind of a requirement when you're using move to line 2 and close path. You want to make sure that you declare this is where our path begins and this is where we're closing it out before we actually stroke it. So let's save that with begin path, refresh, and then hit W, and now we are looking quite good. We're moving over to the right. There's no trail or anything. So I guess it does make sense when we hit W to be going to the right because that is where our spaceship is pointed towards. And W is just going to thrust our spaceship forward while A and D are going to rotate our spaceship left and right. That's kind of the mechanic which makes Asteroids pretty cool is they use rotation on A and D and then they use W to go forward in whichever direction you're in. So the next thing we need to do is figure out how do we rotate our spaceship whenever we press down A or D. Well, here's what we are going to do. The first thing is we want to add in two more key objects within our keys main object. So we can just duplicate the first one of W and then rename it A. And we can duplicate the second one of A and rename it D. So looking good there. And now whenever we go over here to our event listener, we want to make sure that when we call a case of A, that we set our a.pressed equal to true, and then same thing for D. Keys.d.pressed should be equal to true. We can get rid of these console logs, no longer need those. But how do we actually stop our player from moving in the first place, and how would we stop our player from rotating if we were to press down A or D? Because we're setting these equal to true, but we're never setting them back equal to false. To set these back equal to false, we want one more event listener. So you'll see right there, I just copied this full event listener with all of our cases inside of it, and I want to paste it down below. We're going to listen for another event, and that event is going to be key up. Really, really cool. So whenever we release a key, we're going to press down, and then we have to release at some point. We're going to call all these switch case statements right here. And I don't want to set these equal to true when we key up. I want these equal to false because we know whenever we key up on that key, it's going to be equal to false. Would not make sense to keep that equal to true in this case. So let's test this out real quick with W, save and refresh. If I hold down W, we go over to the right. If I let go, we still go to the right because we need to, within our animation loop, declare that if our key W is not pressed, which is pretty much any instance in which this if statement is not called, our player.velocity.x is going to be equal to 0. This is the exact same thing as saying else. Player velocity x should be equal to 0. This right here is the same thing. This is just a little cleaner because we don't need that else statement in there if we call things like this. It's always going to be equal to 0 to start. Then if we hold down W, we're setting it equal to 1. And if that's the case, we should have start stop functionality. Hold down W, release. See my hands? We stopped. Good, 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 good. So we want to begin rotating our player left and right. I mentioned that. How do we actually do it? Well, what happens if keys.d is pressed? What do we want to do? We want to start by selecting our player rotation, and we're going to be adding on to the current value with plus equals. What are we going to be adding on to this? Well, a very small value to start, something like 0.01. Because we're not using degrees here. When we're talking JavaScript angles, we're always going to be using radians. And radians is just a fancy version of degrees. If you have not used them before, I always recommend checking out Khan Academy for an in-depth deep dive, but I will do my best to explain them to you as we go about this particular lesson. So first thing first, we have player.rotation being referenced, but if we look within our player class, rotation doesn't actually exist here. We want to add on that property by going inside of our constructor, declaring that this .rotation is equal to 0 to start. We're not actually going to pass this through as an argument. We don't need to. We just want a 0 radians rotation to begin drawing this. So now when we call this code down here, when we press D, we're adding on to this value right here. And we can begin using this value within our draw method to actually begin rotating our player. So rotating your player within Canvas is always a hassle. I really wish that there was an easier way to do this with the current API, but unfortunately the API has not been updated in years, forever almost, and it's really annoying to do. But I'm here to teach you exactly how to do it with as little pain as possible, so here we go. The first thing we want to do is call something called c.save, and then at the very end of everything, we're going to call c.restore. So when you use save and restore together, we're basically saying whatever code is encapsulated between these two, so everything right here is going to be called within its own little context. So we're about to use a global rotation method, and it looks a little something like this, c.rotate. When we call c.rotate, we're basically rotating the whole canvas. So this is our canvas. If I were to rotate this, then it would be drawn a little something like this. We're rotating the whole canvas based on this one point right here. We don't want to do that. We only want to rotate our one particular object, and you would think calling c.rotate right here would rotate just the one object. It does not. It rotates the whole canvas. Super annoying, but we can still use it to rotate our object with a little bit of handiwork. So instead of rotating from this top point right here, we're going to call save to say that this code, this rotate code, should only be called for the rest of the code within save and restore. Now, where do I actually want to rotate from? Using these two really jank rectangles that I have shown right now, we know that our player, our rectangle, or our triangle per se, is going to be right here in the middle of the screen. I'm using a rectangle just for illustrative purposes. I actually want to rotate from the very center of this rectangle, not the top left of our canvas. So what we need to do to make this work with canvas is we need to translate our canvas location, this big red box right here, to the very center of our player. If we do that, the canvas is going to be right here. And what can we do? We can call rotate right after this. And if we call rotate right after this, what we're going to do is we're going to rotate our canvas again. So the canvas is going to be rotated to look a little something like that. But at the same time, if we're rotating from this one point right here, what else is going to rotate? Well, our actual player will be rotated too. So this blue box represents what this red box would be looking like if we were to rotate it from this position. So we're going to translate downwards to the center of our player, call rotate, and then we need to translate this original canvas right here back to its original position to the top left-hand corner. And if we do this in the correct order, and we do everything, I guess, correctly, we should get the rotational effect. I wish it was easier, guys, but unfortunately this is the way we have to do things. So let's try our best to implement this exact effect. So we have c.save. First thing we want to do is translate our canvas, which we can do with c.translate, and we know we want to go to the very center of our player. We already know the center of our player is position X and position Y. Perfect. So let's say that our X value in which we want to translate our canvas to will be position X, and then our Y will be position Y. So now we're placed at the very center of wherever a player was on the screen. We're placed right here. This is where the big old canvas is going to be. Now we can call rotate by whatever this value of this dot rotation is. So I'll just pass through the property of rotation. We know this is dynamic. It's always going to be changing based on whether a player presses down D or A. And then we want to translate back to our original position. So we'll call c.translate again, and we can't just call 0, 0 because this will actually reference position relative into where we just translated to. It wouldn't actually change anything. We need to specify we want to go backwards with a negative this dot position dot x, and then for y we want to go up by negative this dot position dot y. So this should be all we have to do to get things rotating correctly. Make sure that save and restore encapsulate everything within your player's draw function, and then also make sure that you translate, then rotate, and then translate back with these negatives. So given we did this correctly, let's save, refresh, and then we're going to press down D. And you can see we are rotating to the right. We let go, and we stop because we're no longer adding on to our rotation property. If we hit A, nothing's really happening because we haven't decided or declared what should be happening when we press down our A key. So regarding our player rotation, I'm going to add in else if. That says else if our keys.A is pressed, then our player rotation should start subtracting from itself 0.01. I do that, save and refresh. When I hit A, we go to the left. D, we go to the right. But when I hit W, we still go to the right, even if we were spinning in either way. Not really what we want, but we can fix this with a little bit of our favorite friend, trigonometry. So whenever we press W, yes, we are moving over to the right, but we want our player to move based on the current angle associated with the rotation. So it sounds a little confusing. Let me do my best to explain. I'm going to draw the circle to help illustrate our angles and so forth. Let's say that we move our player to face up towards the top right of the screen. Our player movement is always determined by velocity x and then velocity y variables. So if we were to say we want our player moving upwards towards the top right of the screen, our Vx, and this is really crappily drawn, sorry about that, Vx is going to be equal to something like, let's say, 1. And then Vy will be equal to 1 because we're moving upwards at a rate of 1 pixel per second, and we're also moving to the right at the rate of 1 pixel per second. And since we're adding both of these together, it's going to start shifting us up towards the top right of the screen. Now, let's say we want to go directly upwards within our game. How would we do that? Well, Vx in this case would be equal to what? It would be equal to 0 because we're not actually moving to the right. We are just moving straight up, so Vy would be equal to 1. And these are all just made up values. Of course, these are going to differ a little bit based on what actual properties we use, what speed we use, and so forth. But I just want to help illustrate the idea of how this player movement works based on x and y velocity variables. So what we need to do is start determining dynamically what these two should be in tandem together no matter which direction we face. So let's say we're facing this way. What should x and y actually be? How do we determine these values based off of the rotation of our player? Well, we can use something called sine and cosine. So if we were to draw a right triangle from the center of our player to where they are pointing, it's going to look something like this. We're pointing directly upwards, like so, and a right triangle will look something like this. So what do we need to do here to determine Vx and Vy, or velocity x and velocity y? Well, the first thing we need to do is we need to get our cosine. And what is our cosine? Well, cosine is going to be the ratio of our x-axis distance on this right triangle relative to our hypotenuse. And our hypotenuse is the longest side of the right triangle. It's this green line right here. So how large is this blue line relative to this green line? If we were to lay these out flat on top of each other, we would get some sort of ratio ranging from 0 to 1. And in this case, it looks like this might be something like, I don't know. I'm just going to randomly guess. It's something like 0.8. So that's going to be our velocity value. It's going to push us in the exact correct rate in which we need to start going over to the right by to move our player upwards towards the top right of the screen. But we also need to get what? Well, this side right here, which will be our sine value. What is the sine value? Well, it's the ratio of this side right here, the vertical side, relative to the hypotenuse. This is obviously smaller compared to the cosine. So what would cosine be in this case? Well, cosine would be something smaller. Hypothetically, I'm just going to say it's something like 0.4. So if we're moving upwards at a rate of 0.4 and we're moving to the right at a rate of 0.8, it's going to start shifting us upwards towards the top right of the screen. Maybe not at the exact rate I have drawn this diagram because I'm using made up numbers, but I just want you to understand how I'm getting the velocities right here. We're using cosine and sine, which are simply just ratios of this right triangle relative to the hypotenuse. And if we get those in tandem together, it's going to give us the correct velocities we need based on the angle in which we're using. So to get these two values, we can use functions that are provided to us with JavaScript. So we can use a math.cosine function. It's going to look like this, math.cosine. And this takes an argument, and it's going to be an angle. I don't know what the mathematical term for angle is, so I'm going to use A. And angle is going to be the angle associated with this right triangle. This is the rotation that we're using for our player. We don't have to do anything complicated to get this angle. We already have it. All we really need to do is plug it in to this equation right here, and then we're going to use this to set our player's x velocity. And if we do all this dynamically, I promise you our player will be moving in the right direction. So here's your crappy lesson on trigonometry from someone who has always sucked at math until I really started trying in college, actually. But I hope that helped a little bit. So let's start implementing that to the best of our ability. We want to do what? We want to move our player based on the cosine and sine values of our angle. And we know we're supposed to start moving our player whenever W is pressed. So whenever W is pressed, we're no longer just going to set a bare velocity of x equal to 1. we're going to set both an x and a y for our player velocity. And these can't be equal to just 1 by default. That'll just always send us towards the top right. We want to base this off of math cosine and math sine. So the x value is always going to be cosine. So I'll use math.cosine. And this math object comes with JavaScript by default. We don't need to import anything. We can just start using it. So we'll call math.cosine. And what do we want to put in here? Well, our current player rotation. This is the angle in radians of our player. And if we call math.cosine, it's going to give us that perfect ratio relative to the hypotenuse that we need to start moving in the correct direction. All we need to do now is change our y to math.sine and do the exact same thing. We're going to use the same angle. And that should be it. We should start moving correctly with this code. So let's save, refresh, I'll angle upwards, and then hit W. And you can see we're going in that direction. Now we are continuing to go in that direction because we never actually set velocity.y equal to 0 when we lift up on a key. So let's save that, refresh, and try again. I go up, I stop, and then we stop. And then I can turn around and I can just keep holding it down. And now we have this really, really nice effect right here. It's a little slow for my liking. So if I ever want to speed this up, we can just multiply both of these velocities right here by a higher value. I'll do something like 3 to start. And if we want to be extra explicit, we can declare what 3 is, so we only have to change it in one spot. If that's the case, we want to create a const outside of our animation loop. We don't need to declare this multiple times. So I'll create a const. And one convention for creating constants that are actually like just number constants is to uppercase the constants, like speed, and then set it equal to your value. You don't need to do this, but I've seen this across a couple of projects. I personally like it, because that way I know that this is something that's declared pretty much within the main scope of my project, and it is a constant which should not be changed. So now I know that this is the speed of our player, and I can change it in one spot rather than having to change it multiple times if I were to just use a normal value like 3 right here. So let's save that, refresh, and now when I hit W, we're moving a lot faster. But it's kind of impossible for me to rotate fast enough to where I can really get some precise movements. So if that's the case, I want to increase our rotation speed as well. And we can create another constant for that. Instead of just speed, I'm going to call this rotational speed. And then I want to set this equal to, I don't know, let's say 0.05. Right now we're using 0.01 in both locations. So I think speeding this up by 5 times should be enough. Hopefully not too much. But that should be good. Let's save that in that location. Refresh. And now we spin pretty quickly. I really like how that feels. And oh yeah, I think that might be it for my particular game. Feel free to tune this up as you would like. But I think that's really responsive and snappy. I really like how that's looking. Now, the last thing I want to do before concluding this lesson is I want to add a little bit of friction here. You see, as soon as I lift up, we stop immediately. It would be nice to kind of decelerate into position rather than just stop to give off a really nice effect and feel. And it's really easy to do. A lot easier than you might think it would be. So here's how we're going to do it. If W is pressed, yes, we're going to do all this other stuff, but else if our keys of W is not pressed, which we are indicating with our bang operator right here, saying we're doing the opposite, we want to call the following code. We're going to take our velocities, so player.velocity.x, and then multiply it by a value like 0.99. What this is going to do is slow down our player's velocity for every frame of our animation. So let's say our velocity is equal to 1. We go on to the next frame, and we call 0.99. This means the next frame our velocity will be 0.99. We do this again. Let's say we multiply it by 0.99. Then our velocity will be 0.98. And this is just going to keep getting smaller and smaller over time until it hits something close to 0. So it's a really nice way to kind of interpolate down to 0 rather than just stop instantly. And if we don't want to stop instantly, we need to make sure that we get rid of these two lines right here in which we're setting x and y equal to 0. So our x will be slowing down over time with this line right here, but we also want our y to slow down. So we'll declare we want velocity y to multiply by itself by 0.99, and it should slow down our x and y accordingly so that we decelerate no matter what direction we're going in. It's going to create a really, really nice effect. So let's save that, refresh, and now when I hit W, you can see that it takes a little bit of time to slow down. And I really, really am liking this. Like, this is really smooth, especially for games that I create, because most of them don't go this smoothly. But I think that might be a little too much for my taste. So if that's the case, I can always slow this down. It's also a good instance in which we might want to declare a const. So we'll say that our const is going to be friction, because that's kind of what this represents, is a friction value in which we start slowing down over time. And I want this equal to, let's say, just slow it down a little bit, to 0.97. Now I can change both of these values with friction. Now I only have to change it in one spot. Save and refresh, start moving. And yeah, I think that's definitely the money right there. We're not moving too far, but definitely far enough to give us that nice little movement effect right there. So 0.97 is the money value. And I think that is going to be it for this lesson. So let's head back on over to Move and Rotate Player.